Okay, this is Unit 2, Lecture 5. This is the endocrine system and also different ways that we study the brain. So we've talked about the nervous system. We've talked about neurons that communicate through the nervous system. We've talked about different parts of the brain. So now we're going to take a look at the endocrine system. And we're also going to take a look at different ways to study the brain, looking at it, listening to it, all of these different things where we can sort of see the brain in action and sort of the technology that is behind that. So this is Unit 2, Lecture number 5. So let's talk about, let's talk about the endocrine system. All right, the endocrine system is different from the nervous system because the nervous system is, let's review real quick. The nervous system is electrical signals. The nervous system travels extraordinarily fast. And again, I know we're a half second behind or whatever, but it's pretty quick. For example, if this hand wants to grab this pen, okay, the message goes from my brain, the left motor cortex, down through the spinal cord, switching at the reticular formation, coming down the arm, and it tells my right fingers to grab it. And again, grab it, fraction of a second. And by the way, this command from the left part of my motor cortex to the hand to close it, it's specifically between those two. It has nothing to do with my left elbow. It has nothing to do with my right pinky toe. It is simply between here and here. It's a very isolated message. It's a very quick and instantaneous message. And once it's grabbed, the relationship is over, at least for that particular message. There's not going to be any lingering effects or anything else like that. That's the nervous system that we have talked about before, where it is efferent neurons exiting the brain, motor neurons telling us grab it. And then once I grab it, they are sensory neurons that are sending it back to the brain in order to pick that up. Okay, so the endocrine system, sorry, brain went to the Bahamas there for a second. The endocrine system, this is a little bit different because unlike communication through electrical signals, which is very quick and very isolated, the endocrine system communicates through hormones. And hormones take longer because hormones are delivered through the bloodstream. And the bloodstream goes all over our body. So when I am getting a message from my stomach telling me that I am full, it goes through my whole body, taking a look at the glucose level and everything else to get the message up to my hypothalamus that maybe I need something to eat or whatever else the case may be. So it's got to go throughout my whole body. Okay, so first off, my entire body gets involved. Secondly, it takes a while. It's not immediate, grab the pen, grab the marker. It's not that immediate. It takes a while. As a matter of fact, when you are eating dinner and your stomach says, that's it, I've had enough food, I am full. By the time the message goes from your stomach and works its way through the bloodstream and gets up to your hypothalamus, the want center, and says, hey, put the fork down, we're full. It takes about 15, 20 minutes. 15 or 20 minutes after your stomach is full for you to tell your brain that's enough, stop eating. And this is why very often we eat, we put the fork down because, oh, I just got the message that I'm full. And about 15 minutes later, we're like, oh, because we're 15 minutes late. By the time we stopped eating, we were full 15 minutes ago. And that's some of the problems we have with listening to our body through the endocrine system. When I see somebody cut me off and it makes me angry, the testosterone, the hormone of testosterone goes throughout my entire body. The hormone of adrenaline doesn't just get me to focus on that guy, it also gets my body moving. So again, hormones, the entire body gets involved, and it's slower communication. And then once it's over, it's still there. The guy cuts you off and leaves, and you're like, "Ah, you son of a bitch, he's coming off," and whatever. And okay, well, he's gone now, and now I just need to drive, but now I'm still shaking because all that adrenaline is in my body, all that testosterone and anger is in my body, and it doesn't just go away. And we'll talk about that with stress, because a lot of times what happens is we build up this adrenaline, we build up this testosterone, we build up this rage all day, and we never use it. So we sit in this corrosive bath of hormones that a lot of times never get used. That's the endocrine system. That's communication that we're talking about. So again, we're talking about communication through hormones. Hormones are chemical messages, mostly those manufactured by the endocrine glands. Some of them are outside, produced in one tissue. They affect all other tissues. Increased levels of hormones tend to act as enhancers of human behavior. High testosterone levels have a greater impact on a person who already has naturally aggressive tendencies. If I'm someone who is not a naturally aggressive person and you give me a shot of testosterone, it's not going to impact me as much as someone who's naturally more aggressive. So you got to think of hormones kind of like a spice. It will just basically enhance sort of what you already are or what you tend to be. One of those types of hormones that we'll talk about quite a bit, especially when we talk about stress down the road, is adrenaline. Adrenaline comes from the adrenal glands, which are these two little beanie caps on top of our kidneys right here. And they are the ones who basically secrete the hormone epinephrine and norepinephrine, which arouse the body in times of stress, gives us that extra energy where we can run the extra distance, get that little reserve tank of whatever. Even after the stress is over, though, the rush can still be there, unlike a neuron. You're still, even when the test is over, you're still a little bit shaky or whatever. Women also tend to get testosterone through the adrenal glands because women obviously don't have testicles, which is where men get their testosterone from. So they get their testosterone from the adrenal glands. Now, the pituitary gland is very important, because the pituitary gland, which is a little pea-shaped thing right here, is connected directly to the hypothalamus. So it is the connection between the nervous system and the endocrine system is right here. So the pituitary gland, this little pea-sized thing in our brain, is there to regulate the entire endocrine system. Now, again, it releases its own hormones, regulates growth, blood pressure, water regulation, temperature, making sure we're not too high, not too low, all these other things. For women, pregnancy, our metabolism, our ability to digest food, all these things get worked out through the pituitary gland. But the more important function, in my opinion, of the pituitary gland is that it does work in connection with the hypothalamus to keep the endocrine system and the nervous system communicating with one another. For example, the hypothalamus, and by the way, it also produces the hormone oxytocin, which we talked about before, sort of the love happy hormone. The body sends messages. Let me give you this example. I'm hungry. My stomach is grumbling and it is hungry. Okay, so what happens is I basically send the hormone leptin up to the hypothalamus, and the hypothalamus now goes, oh, I got leptin, I'm hungry. So then the hypothalamus tells us to go to the cabinet, get a Snickers bar, whatever, we eat it, and then we tell the pituitary gland, hey, we ate it, is everything okay? So then the pituitary gland sends hormones down throughout the body to get the blood sugar, whatever, and it gets the other glands as well, and they send hormones now regulating and measuring the blood sugar, and they tell us whether or not we have it. So it just sort of works its way around this. All right, so the nervous system directs the endocrine system, which in turn directs the nervous system, and they sort of work in cahoots with one another. And again, it's the pituitary gland talking to the hypothalamus. That's the bridge between these two. But again, the endocrine system is slow. It goes through the whole body. Nervous system is fast. I'm in the fridge. I'm eating a Snickers bar. Why the Snickers bar is in the fridge, I don't know. By the way, if you ever had a frozen Snickers bar, not the most terrible thing in the world. Kind of like a fudgesicle with the peanuts. All right, now let's talk about some other hormones and glands within the endocrine system. The pineal gland, which again is about the size of a pea. I misspelled that. I need to correct that. And it's located behind the brainstem. As a matter of fact, before I forget, if you don't mind, let me just go ahead and correct this now. There we go. Okay, it's about the size, very unprofessional. It's about the size of a pea, located behind the brainstem. Now, the big thing about the pineal gland is and we'll be talking about this when we get to sleep. And by the way, I apologize. We're on unit 2, and you've already heard me say again and again and again, and we'll talk about. I'm going to probably be saying that all semester up until unit 8 when we talk about disorders and therapy. And by then, there's no more tomorrow. It's a continuation. But anyways, the pineal gland, one of the hormones that it produces is melatonin. And melatonin is produced during the evening to encourage sleeping. When it starts to get dark outside, as it is right now, my body is producing more melatonin. Now, the trick here, again, it is June 28th that I am recording this, and now the sun doesn't set until like 8:30 at night. So it takes a little bit longer for my melatonin to start getting produced. So this encourages sleeping. It solidifies our circadian rhythm, which is our natural body clock, which we'll talk about when we get to sleeping in a little more detail. And it's also very important in protecting and healing brain cells, which is why we want to go to sleep, so that this melatonin can go in and sort of fix things around there. It's produced much more right now when it's a little bit dark. But one of the problems is a lot of you guys have your little smartphone, and at night while you're lying in bed, you're reading your smartphone, and the blue light that is produced from that actually suppresses the production of melatonin, making it harder to sleep, which is why you've got to watch what your screen is putting out there. There's apps that can actually reduce the blue light in there so that you can fall asleep a little bit easier. Gets thrown off by time changes, gets thrown off by longer days, all these things, which is why your body needs to sort of stick to a schedule as much as you can. Typically, it rises about 8 p.m., peaks at 3 a.m., and then soon drops off so we can wake up in the morning. Young children produce it earlier, adolescents, and we'll talk about this when we get to sleep, you produce it later, which is why you guys tend to be a little bit more of night owls. Insomnia is contributed to not producing this as much. Seasonal affective disorder can be treated with melatonin, which is people who are a little bit sensitive to the winter blues because there's not as much daylight during the winter. Your thyroid, on the other hand, this produces thyroxine, which is more about the energy levels that we have. Not a lot of significance there within psychology, but sometimes people can have a little bit of a thyroid fatigue, which means that their energy levels could be off. When we talk about the sex glands real quick, and again, I know it should be ladies first, but let's just talk about the testes. The testes produce sperm reproduction. Androgen and testosterone are both produced by the testes for men. And here's what's very important to know. Men have levels of testosterone. Men have levels of estrogen. Women have levels of testosterone. Women have levels of estrogen. Men tend to have greater levels of testosterone. Women have greater levels of estrogen. So let's kind of stick with those parameters there. And again, what you're going to probably, some of you will complain about with this class is everything that I talk about is based on heterosexuality. You know, there's a lot of, well, what about homosexuality? What about transgender? What about bi? What about non-binary and all these other things? If there were more studies that have been, we could look at it more. It's just that a lot of these things have not been, what's been studied more than anything else is heterosexuality. And with heterosexuality also being the vast majority of the population, a lot of what we're going to talk about is going to focus on that. And now that is not to say that there's not information out there. There's a lot of information out there. And if you have an interest in that, I would highly recommend that you go out and you search that. But for a survey class, to try to get everything in one semester, we're going to keep it to some common denominators here. All right. Again, testosterone more predominant in men, linked to aggressive behavior, including overconfidence, optimism, cocky, egocentric, narcissistic behavior tends to be linked to testosterone. A winner effect. After winning a fight or other activity, testosterone actually increases the pleasure, makes us want to go again. Aggressive behavior increases production, but also the production increases aggressive behavior. Lower levels in females, male produce it 7 to 8 times. Now, for someone who may be transitioning, let's say you were born with female anatomy and you're transitioning to a male life, one of the first things that they would do is you would start with hormone therapy, which is high levels of testosterone to help the transition. And what the effect that this has is it changes, your voice becomes lower when you get higher levels of testosterone. Your muscular build changes, it gets a little bit thicker. Weight distribution is more on the trunk than it is on the hips. All of these things are affected by levels of testosterone changing. Now, on the other side of the equation, women with ovaries produce eggs for reproduction, obviously, but they also produce more estrogen and progesterone. This is very, very important to the reproductive style, the menstrual cycle, PMS, menopause, all these things, lower levels in men. And again, if you had somebody that was born with male characteristics and they were transitioning to a female, one of the things that they would start is hormone therapy with estrogen, which would not give them the ability to reproduce, but it would change. There would be less facial hair. Their fat would be distributed from their trunk to more of their hips. Their muscles would become leaner. Less hair on the arms and around the body. Your voice might raise a little bit and have more traditional female characteristics, if you would. Okay, so a little bit going on there. All right, now let's talk about leaving the endocrine system behind. Let's talk about the brain and how do we study the brain. Well, when we study the brain, we're looking for certain irregularities a lot in the brain. And one of the things a lot of scans of the brain look for are things like lesions. Here you see someone who had a stroke where part of their brain is destroyed, or MS, where you're starting to see these little emptiness things going on in here. And over here, you can see an irregularity as well. So one of the reasons that we study the brain is we can actually see dysfunction that's going on in there, repairs that need to be done, damage that has been done. So we talked about this young girl before. Now, different ways that we can study the brain. One way to study the brain is what is called an EEG, which is electrosonographic, where we're going to take, sonograph. What we're going to do, I kind of stumbled over that, is you take little microphones, you put them on a skull cap, as you see with the little baby here, and the job is these little microphones will actually measure the brain waves, and depending on the size of the brain waves, you can tell the amount of activity that is going on, and specific brain waves are specific messages and everything else. If you have really small, tiny waves, this is very active. These are gamma waves. Beta waves are a little bit larger. Alpha waves a little bit larger, bigger gap. Theta waves, very small, huge gap. Delta waves, very slow. Now you see these when we take a look at the different stages of sleep. When you have somebody awake, their brain is very, very active, relaxed, and drowsy. These waves get a little bit bigger because your brain's not quite as active. Then as we start to fall asleep, these waves have bigger gaps in them until you get into stage 4, which is the great money sleep. You get these nice big delta waves here and big gaps, and your brain slowed down. But then when we dream, our brains become very active, almost to the same level of being awake, which is why we don't dream all night. But anyways, when we take a look at this right here, you see an EEG before a seizure. This is normal brain activity, and you can sort of see the yellow right here showing you the sort of up and down, up and down, up and down, up and down. Then if we take a look at this right here, this is somebody during a seizure, and you notice the radical movements of these waves compared to a little bit. This is normal activity. This is a seizure. This is when the brain is overwhelmed with electricity and where people have convulsions and are out of control. And then after the seizure, we're kind of back to normal. It looks more like that. It's not as scattered as that. All this can be measured in an EEG. Another EEG here, when you take a look at the waves as somebody is sleeping. Let me go back again. So this is awake and then relaxed, stage 1, 2, 3, 4. And I got the nice big waves in stage 4. But now my problem is I'm back in 3, 2, 1, and now I'm dreaming in REM sleep. Okay, so that's very active. 4, very slow. Get back up here into REM sleep when I'm dreaming, and you'll notice it's very, very jagged. We get back down here into stage 4, and it's very, very slow. And these are just the basic wave sizes that you can measure. All of this happens with an EEG. Okay, a CAT scan, which I'm sure many of you have had a CAT scan, measuring for concussions and anything else. A CAT scan is like cutting and slicing through the brain. You're taking different slices, start at the top, slice it, slice it, slice it, slice it, get down to the eyeballs here. You're just basically taking pictures. And this is a 2-dimensional image, which could be put together to make a 3-dimensional image. But a lot of times, again, you're looking for tumors, you're looking for swelling, you're looking for pressure, you're looking for concussions. Any irregularities in the brain can be done by a CAT scan. Now, if this isn't good enough for you, sometimes you can go with an MRI, which we'll talk about here in a second. A PET scan is where you take a CAT scan. So you take the slices and you combine it with activity that's going on in the brain. You give somebody a little dye, it goes into their brain, and you can actually see the brain light up with activity. For example, this is a PET scan. And again, where the positioning of the action is, this is somebody who is seeing words. Notice that their occipital lobe is really lit up. This is somebody who is hearing words. Notice their temporal lobe really lit up. Okay, so you can see where the specific activity is in the brain when you take a look at a PET scan. Where you have the warmer colors, there's more activity. Where you have the cooler colors, there is less activity in the brain going on. When you look at the brain development of a 1-month-old, not a lot of activity versus a 12-month-old, much more active. When you take a look at the frontal lobe of a normal person right here, very active. A person who's a murderer, doesn't see the consequences, doesn't know how their actions hurt other people, less activity. We see somebody over here with that is not depressed, normal lit up activity versus someone who's depressed, not as much activity, especially in the frontal lobe, although their amygdala is lit up. You see somebody with normal control of their life right here, OCD, and overactive frontal lobe, trying to overcompensate for a lot of things. All of this can be seen in the brain once this dye is put in, and then you ask them to sort of respond to particular things while in the machine. An MRI is a 3-dimensional picture of the brain in action. And I'm sure a lot of you guys have had MRIs done on your knee, your shoulder, your elbow, whatever, where the doctor can sort of get a good look around on everything that's going on in there. So it's like a CAT scan, except instead of being 2-dimensional, it's 3-dimensional. It allows you to see the structures of the brain. You'll see this is an MRI just sort of working its way through. We're coming up to the top of the head right here as it's gone through the rest of the body. So there I'm at the top. And then you see the nose and the eyeballs right there working its way up. Here you see the brain going from the back to the front. And this one's going from the left to the right. I'm sorry, this one's going from the front to the back to the front. This one's going from the front to the back there, and this one's going from the top down. So these are great 3-dimensional pictures that can be taken of the brain in action, different ways that it's there. Okay, so that wraps up the endocrine system, and it also wraps up ways that we study the brain. Now, next we're going to talk about evolutionary psychology. And evolutionary psychology is basically the idea of why are we what we are? Is it based on the genetics that we get, or is it based on environmental experiences? And something that I like to do is this little excuse me, exercise right here. I would sometimes do with my on-level classes. And this is a study that's done where they take people and they give them these 18 different characteristics. What are you looking for in a mate? Not somebody that you're going to date, but someone you're looking forward to be with for the rest of your life. How would you rank these things in order? Ambition and industriousness, chastity, dependable character, desire for home and children, education, intelligence, stability, emotionally, favorable social status, good cook and housekeeper, financial prospect, health, looks, mutual attraction, pleasing disposition, refinement and neatness, education, political, religious background, social ability. This was done about 7-8 years ago. And they would have men and women take this and rank on what they think is important. And you basically put it into 3 categories. The 6 most important, if you got 18, your 6 most important are deal breakers. Your middle 6, it'd be nice if they had it. If not, no big deal. And your bottom 6, whatever, who cares? So what do women want versus what men want? I'm just going to go through this really quickly, and we're done with the lecture. You could shut it off right here if you'd like. But when it came to ranking these 18 characteristics, women ranked as the least important one, chastity, prior sexual experience. When it comes to men, they look at that as the least important thing. So then we take a look at men. Would men be different? Would men put it just as low? Would they put it higher? Would they put it significantly higher? And in cross-cultural studies around the world where this test was given about 6 or 7 years ago, men put it right about the same. All these things in green, whatever, okay? Women put second least important, similar political background. Now, please, the caveat here is this was 2012 when this was done. This was not 2020. This was not 2016. This was before that. Maybe this pops up a little bit higher, who knows? But women put that as 17, second least important, and men put it as the least important thing. Because odds are, if you're interested in someone, you're probably going to have similar cultural values and whatever else. Good cook and housekeeper, women expecting that of men at 16. Men did put it a little bit higher, but not all the way up into that middle group yet. You know, guys can make an egg. They're okay there. When I say egg, I say an egg you eat, not actually ovaries going on there. Similar religious background, women put that at 15. Men put it also at 15. Favorable social status, women put it 14. Men put it exactly the same. Good looks, women put good looks at 13. Would guys put it in the same place? No, higher. But how much higher? 7. Not in the top 6, but they put it at 7. Now, here's what's also important. What is considered good looking? It's different between men and women. Women look at more of a collective thing. You know, if a guy is generous, has a sense of humor, all these other things can make him more attractive. Whereas guys, it tends to be a little bit more physical when you're younger. As you get older, it becomes more of a whole package thing. But women are a little bit ahead of the curve on that. Refinement and neatness, it gets into the middle row. Women put refinement and neatness at 12, men pretty close. Good financial prospect, women put that at 11, guys put it much lower. So we've got both of the bottom groups wrapped up here, very similar. Similar education, women put at 10, men put at 12, pretty close. Good health, women put at 9, men you got into the top 6. Because when you're talking about good health, women look at good health and they're like, is he a good health that he can be a provider? Men look at good health as she good health where she will be able to have my child and that will be healthy. And we'll talk about that with evolutionary psychology. Women put sociability at number 8. Do I like to, if I like to go out, they like to go out. I like to stay at home. They like to stay at home. Women put it at the same. Women put desire for home and children at 7. Men put it at 9. Women put ambition and industriousness at 6. Men not expecting as much from women. Again, 8, 9 years ago. Could it change? But notice 6 through 18 are all off the table. So our top 5 between both of them are made up of the same things. Education and intelligence, the same. Pleasing disposition, the same. Dependable character, the same. Emotional stability and maturity, the same. Mutual attraction, the same. Are men and women different? Sure. We're all taking in oxygen. We're all kicking out carbon dioxide. We all want love. Kind of the same. So we're going to take a look at that over the next couple of lectures as we talk about evolutionary psychology. That's what we're going to pick up on next. Okay?